Trigonometry, finding the area of a triangle. Finding the area of a triangle using trigonometry. Suppose we've got a triangle ABC with the length of the side opposite the angle A being little a, the length of the side opposite the angle B being little b, and the length of the side opposite the angle C being little c. Then we have the area of the triangle ABC is equal to a half times the length of side small a times the length of side small b times the sine of the angle C. In other words, we can say the area of triangle ABC is equal to a half AB sine C. Now we can prove this. We first need to draw a perpendicular line from A to BC at D. So AD is the altitude of the triangle. Let AD equal H. Now, in triangle ADC, if we consider the angle C, then H is the opposite side and B is the hypotenuse. Now we know the sine of an angle is the opposite over the hypotenuse. So H over B is equal to the sine of C. If we multiply both sides by B, we get H equals B times sine C. Now we also know the area of a triangle is equal to a half times the base times the height. So in the triangle ABC, the area is a half times CB times H. But we've just shown that H is equal to B times sine C. We also know that the side CB has length A. So the area of the triangle is a half A times B times sine C. Or area of triangle ABC equals a half AB sine C. Let's look at a couple of examples. Example 1. Find the area of the given triangle. Now we've got a triangle ABC with the side BC being 6.7 centimetres and the side CA being 7.6 centimetres. We're told the angle C is 128 degrees and we want to find the area of the triangle. Well, to solve it we can use the triangle formula. The area is a half times A times B times sine C. Now we've got A is 6.7, B is 7.6 and C is 128 degrees. So the area is equal to a half times 6.7 times 7.6 times the sine of 128. Well, we can type that into a calculator and we get 20.06275. So if we round that off to one decimal place, we get the area is equal to 20.1 square centimetres. Let's look at another example, example 2. Find the length x in the isosceles triangle if the area is 140 square centimetres. Now we've got the triangle ABC, C is 28 degrees, and AC and CB are both length x. Now the area is a half AB sine C. So it's a half x times the sine of 28. In other words, a half x squared sine 28 equals the area, which is 140. So if we double both sides and divide by sine of 28, we get x squared equals 2 times 140 over the sine of 28 degrees. Which comes out to be 596.415. Now, if we take the square root of both sides, we get x is the square root of 596.415, which equals 24.42. So, rounding it off to one decimal place, we get x is equal to 24.4 centimetres. Now, the following is an exercise based on the triangle formula, which is the area of the triangle is a half AB sine C. Pause the video at this point, have a go at these questions, and when you've done them, restart the video and I'll go through the answers. Okay, let's have a look at the solutions. Now for the first triangle we've got sides of 6 centimeters, 7.4 centimeters and an angle between them of 78 degrees. So using the area is a half AB sine C, A is 6, B is 7.4 and C is 78 degrees. So the area is a half times 6 times 7.4 times the sine of 78. Well, if we type that into a calculator, it comes out as 21.71488. Rounding that off to one decimal place, we have the area is equal to 21.7 square centimetres. In question 2, we have a triangle with sides 12.5, 17.5 centimetres and an angle of 26 degrees. So if we want to find its area, we use area is a half AB sine C, where A is 12.5, B is 17.5 and C is 26 degrees. So the area is a half times 12.5 times 17.5 times the sine of 26, which if we put it into a calculator gives 47.94685. So rounding it off, we have the area is 47.9 square centimetres. In question 3, we have a triangle with sides 11.4, 9.6 and an angle of 122. So, using the triangle formula, half AB sine C, we have A is 11.4, B is 9.6, C is 122 degrees, and so the area is a half times 11.4 times 9.6 times the sine of 122, which, when we work it out on a calculator, is 46.40519. So, if we round that off to one decimal place, the area is 46.4 square centimetres. In part 4, we have a triangle with sides 14.4 centimetres, 8.1 centimetres and an angle of 98 degrees. We again use the triangle formula. The area is equal to a half AB sine C. This time we've got A is 14.4 centimetres, B is 8.1 centimetres and the angle C is 98 degrees. So the area is a half times 14.4 times 8.1 times the sine of 98 degrees, which if we type it into a calculator comes out as 57.75243. Now if we round that off, we get the area is 57.8 square centimetres. If we look at part 1 of question 2, this time we're given two sides and the area and we're asked to find the angle theta. So we're going to use the same formula. The area of the triangle is a half AB sine C. So a half times 8.4 times 12.3 times the sine of the angle, the sine of theta, equals the area, which is 50.1. Now we can multiply both sides by 2 and divide both sides by 8.4 times 12.3. And that gives us sine theta is equal to 2 times 50.1 over 8.4 times 12.3, which on a calculator works out to be the sine of theta equals 0.9698. Now that means theta is the inverse sine of 0.9698, which comes out to be theta is equal to 75.88 degrees. But theta can also equal 180 minus that, so theta could equal 104.12 degrees. So we've got two answers. Theta equals 75.9 degrees and theta equals 104.1 degrees. However, if we assume that the diagram is reasonably accurate, then we can assume that the angle theta is an acute angle, so we can assume that theta is 75.9 degrees. Now in question 2, one of the sides is missing, but we have one side, the angle, and the area. So using the area of a triangle formula, we have a half times 6.9 times x times the sine of the angle, 68 degrees, is equal to the area, 26.9. Now we'll have to multiply by 2 and divide by 6.9 and sine 68, but that gives us x equals 2 times 26.9 over 6.9 times sine of 68. Well, this works out to be 8.409. So we can say x is equal to 8.4 centimetres. If we look at question 2, part 3, this time the angle is not given. That's what we need to calculate. But we still use the same formula. The area of a triangle is a half AB sine C. And we have a half times 6.1 times 6.1 times sine theta equals 16.1. So if we multiply by 2 and divide by 6.1 times 6.1, we get sine theta equals 2 times 16.1 over 6.1 times 6.1. Now that tells us the sine of theta is 0.8655. If we take the inverse sine of that, we get theta is equal to 59.92 degrees, but we can also be 180 minus that, so theta could equal 120.08 degrees. So our answers are theta could be 59.9 degrees or 120.1 degrees. If we assume that the diagram is reasonably well drawn, then we have theta is an obtuse angle, and so we would have to choose theta is 120.1 degrees. Now in part 4 we have the area of a triangle is a half AB sine C, but this time one of the sides is missing. So putting things into the equation, we have a half times 8.4 times x times sine of 42 is 18.0. Well, if we multiply by 2 and divide by 8.4 times sine of 42, we have x is equal to 2 times 18.0 on the top and 8.4 times sine of 42 on the bottom. So x works out to be 6.4049. So rounding it off, we get x is equal to 6.4 centimetres. With the area of a triangle formula, it's worth remembering it in the form: the area of the triangle is a half times the length of one side times the length of another side times the sine of the angle between them.